I spend a lot of time scrolling through GitHub. The trending tabs, it's usually a pretty predictable rhythm.
Right.
You've got your new JavaScript framework, maybe a transformer model from a research lab, but in early 2026,
Oh.
something just, well, broke the pattern.
Bizarre is putting it mildly. It was an anomaly, really.
Right. This sudden, just vertical spike in traffic for a repository called n2nhu Labs Universal Game Engine.
Hmm.
And in just 24 hours, 131 developers cloned it, which, for some random repo with zero marketing, that's a huge number.
Especially when you figure out what it actually is.
Exactly, because on the surface, you read the README, it looks like a throwback, a text adventure.
Very Zork.
Totally. You're in a dungeon, there's a sword, there's a troll, classic stuff.
And my first thought was just, why? Why is the tech world in 2026 suddenly obsessed with a text game?
It's a fair question. I mean, we have VR, we have photorealistic rendering. Why go back to ASCII?
But that's not it, is it?
No. The developers cloning this weren't looking for a game. They were looking at a manifesto. A manifesto disguised as a dungeon crawler.
Precisely. What a developer named JP Ames built here isn't really about killing trolls. It's a statement, a radical take on software architecture that rejects like the last 20 years of best practices.
And that is what we are digging into today. Because I opened the source code and the 300-page PDF that came with it.
Applied algebraic design.
Yes. And I realized this team claims to have built a massively multiplayer online game in just 6 hours.
6 hours, using tech that existed in 1978.
So that's our mission for this deep dive. How did they do it? We're going to look at why they use SSH as a game client. We're going to break down the math they call algebraic design. And maybe most importantly, we're going to uncover why this isn't really a game engine at all.
But a blueprint for the next generation of AI agents. It's a fascinating case study in how we might be over-engineering, well, everything.
Okay, let's start with the architecture. They call it the atomic foundation. Now, if I were to design an MMO today, my whiteboard would be covered in boxes. WebSockets, a load balancer, Redis, a huge database, a React front end.
The standard stack. It's what we're all trained to do. You need all these layers for state, for transport, for rendering.
And this engine uses none of that.
Zero. It's what they call radical simplicity. There is no game client. You don't open an app. You open your terminal, and you type sesh player at server.
Okay, let's just pause on that. SSH, I use it every day to log into servers. It's an admin tool.
Right.
Using it as a game client just seems clunky. Wouldn't the overhead be huge?
You'd think so. But this is where their COTA philosophy comes in. Commercial off the shelf.
Okay.
Ames argues that we spend weeks building custom auth, encryption, session management. But SSH has been doing all that robustly since 1995.
So they're just getting security and logins for free.
Exactly. They didn't write a single line of code for it. The source material says that by choosing SSH, they just eliminated about 1,500 lines of infrastructure code.
That's 1,500 lines you don't have to debug or maintain. I get the efficiency, but what about the data? I saw in the notes they claim there is no database.
No SQL, no SQL. No database engine running anywhere.
That just sounds like a disaster. I mean, if I pick up a sword in the game, where is that state being saved?
It lives in the file system.
The file system.
Yep. Every player gets their own .json file, jim.json, bob.json.
Just flat files. Hang on. If you have thousands of users all interacting, the file locking is going to be a nightmare. Race conditions everywhere.
That's what every engineer thinks at first. But the manifesto talks a lot about atomicity in POS systems.
Walk me through that, because I think atomicity and I think database transactions.
Right, all or nothing. But the OS has its own version. The engine's rule is simple. Only the process for Jim ever writes to jim.json.
Okay.
When the state changes, the server writes a temporary file and then does a file move, a rename. And in Linux, a rename is an atomic operation. It either happens instantly, incompletely, or not at all.
So they're making the OS kernel their transaction manager.
Exactly. They argue the Linux file system is battle-tested. It handles concurrency just fine if you structure your data this way. And by doing that, they cut their infrastructure code by, 87.5%?
It's a bold move. It feels like it wouldn't scale, but...
But that's the point. They aren't trying to build Facebook. They're trying to build a system that lets them focus entirely on the logic. And that logic, well, that's the real magic trick here.
Right, let's get to the Matrix Revolution. We're not talking Keanu Reeves. We're talking about replacing code with algebra.
This is the absolute core of applied algebraic design.
Yeah.
To get it, you have to understand what they call the conditional nightmare.
The endless if-then statements. The spaghetti code.
It's just unavoidable in most games.
Mhm.
You want a player to eat an apple, you write code. If command is eat and object is apple, then do the thing.
Fine for one item.
Sure, but you add a sword. If command is eat and object is sword, then print. You can't eat that. Now multiply that by 1,000 items and 50 actions.
You end up with these giant nested blocks of code that are impossible to read and slow things down.
Exactly. So their solution is to stop writing logic and start using set theory. They use 3 matrices.
Okay, visualize this for me. When you say matrix, what am I looking at? Big spreadsheet.
Think of it like that. First is the object matrix. It just defines what exists.
Right.
A sword, a sandwich. Then the verb matrix. Eat, attack.
Okay.
Now, the engine doesn't run code to check if you can eat a sword. It does a set intersection.
Meaning, the sword has some properties in a config file.
Right. Sword might have properties like weapon, metal, heavy. The verb eat might require its target to have the property food.
Ah, I see.
So when the player types eat sword, the engine checks if those 2 sets of properties overlap.
And since weapon, metal, and food have nothing in common,
The result is a null set. Action blocked. Instantly.
and that lookup, that's constant time, isn't it?
Yeah.
01.
It is. It doesn't matter if you have 10 items or 10 million. The math takes the same amount of time. The benchmark in the paper says it's about 100,000 times faster than a big conditional tree.
But the real win feels like maintenance. If I want to add a magic wand, I don't have to go edit the eat function.
You never touch the engine code. You just add magic wand to your object list and tag it with magic wood. The engine automatically knows how it interacts with everything else.
So you shift the complexity from the code to the data.
That's the mantra. Data is behavior.
Okay, but a static world is boring. Things have to change over time. How does a static matrix handle physics? Like water freezing into ice.
That's the third one. The transformation matrix. It's basically a state machine, but it's defined in the config files.
The water to ice example from the repo is the famous one, right?
It is. So a player drops a cup of water in a freezer and waits 3 turns.
In a normal engine, you'd have some scripts constantly checking, is it cold here? Is there water?
Which just eats up CPU. Here it's a passive rule. The transformation matrix has a definition. Input, object, water plus environment, cold plus duration. 3, output, object, ice.
So the engine is just pattern matching against that rule every turn.
Yes, and because the rules are totally separate from the objects, you get this emergent behavior.
This is how they built that whole crafting chain, right? Iron ore to ingot to sword.
Without writing a single line of code for it,
Yeah.
they just define the transformations, ore plus heat as ingot. They basically simulated thermodynamics just by defining the rules.
That's really impressive. It gives you this feeling of depth without needing deep code. But what about the things living in this world? The monsters, the brutal troll.
This is where it gets really interesting for AI. They call it intelligence without code.
I feel like intelligence without code is what my boss expects from me.
Well, here it actually works. An NPC isn't a complex script. It uses a sprite matrix.
I'm sensing a theme here.
The NPC is treated just like any other object, but it has a goal. There's this great story in the testing logs. They spawned a brutal troll in the library.
Okay.
And they put a rusty sword on the floor. Now, they had not programmed the troll to use weapons. There was no if weapon nearby, equip weapon script.
So it just ignored it.
No. The troll had one rule in its matrix: maximize potential damage output.
Ah, a utility function.
Exactly. So the engine runs the math. Damage with fists is 5, damage with sword is 12. The math says the state holding sword is better than empty hands.
So the troll did the algebra and picked it up.
It picked it up and attacked a player. The devs apparently freaked out because they thought it was a bug, but it was just the math working. Emergent intelligence.
And that idea, treating players and monsters as the same kind of object, that led to the 30-minute miracle, didn't it?
Yes, rolling out PvP, player versus player combat.
Which is usually a development nightmare.
A total nightmare. You have to build all new targeting logic, special rules. But here, a player is just an object with a property, controlled by a human. To turn on PvP, they just went into the config and flipped a Boolean on the player object. Targetable.
True.
That's it. 30 minutes. A feature that usually takes a whole sprint.
It's just such a compelling argument for getting your foundation right. If the math is sound, the features are almost free.
The complexity is in the behavior, not the code. That's the lesson.
I do want to touch on the visuals, though, because we keep saying text adventure, but the repo has this file, speeches server battleev.py.
This is the bridge. This is where 1978 meets 2026. They integrated Stable Diffusion right into the SSH stream.
How does that even work? You can't just render a JPEG in a terminal.
Well, with modern terminals, you actually can, using certain protocols.
Wait,
But the mechanism is the clever bit. The server reads the game's text log. Jim attacks the shadow demon with a rusty sword.
okay.
It strips out the numbers, the UI bits, and it feeds that narrative text into a prompt engine.
And builds a prompt from it. Fantasy RPG combat scene. Jim swinging a sword at a demon.
Dynamic lighting, yeah. And it generates it on the fly.
Wait, real time and image generation don't usually go together? Doesn't that lag the game?
That's the beauty of it. The text appears instantly, the image fades in a second or two later. For a turn-based game, that latency feels good. It's like a page turning in a comic book.
So you're playing Zork, but with custom AI concept art for every single action.
Exactly. And they didn't have to write an art director. The game state is the art director.
That's wildly creative. But I have to go back to something you said at the start. You said this isn't a game engine.
This is the Trojan horse.
I knew it. That maximized damage logic for the troll sounded a little too much like a sales algorithm.
You are more right than you know. You read the manifesto all the way to the end, to the afterword, and there's this huge reveal.
Which is?
The entire project, the dungeon, the trolls, all of it is a proof of concept for enterprise AI agent.
Okay, map that out for me.
Think about it. What is a player in a game? It's a user entity with a history. In a business system, that's a customer.
Okay.
What's an NPC with a goal that interacts with the player? That's a customer service bot.
And the transformation rules. The water plus cold becomes ice.
If ticket status is open and time elapsed is more than 24 hours, then transform status to escalate to manager.
It's a workflow engine.
It is the exact same algebra. They prove that the code that spawns trolls is mathematically identical to the code that can route support tickets or manage hospital triage.
So they built a dungeon crawler to prove they could run a Fortune 500 company on a folder of text files.
Pretty much. And the real kicker is the cost. Because of that architecture, no databases, no huge cloud services, just SSH and text files. The infrastructure cost is pennies on the dollar compared to running Salesforce or SAP.
That's why 131 developers cloned it. Not to play a game.
No, they were looking for a way to burn down their company's tech stack. They saw a way to replace million-dollar enterprise software with a little bit of math.
It's a sobering thought, really. We're so used to enterprise grade, meaning complicated. We assume we need the Kubernetes cluster, the distributed database.
And this project just asks, do you? Or are you just bad at algebra?
It really makes you look at your own work, doesn't it? I'm thinking about our own internal tools. How much of it is just hard-coded logic that should be data in a matrix?
That's the big takeaway. Look for the matrix in your own work. If you find yourself writing the same kind of logic over and over, you've probably missed a chance to simplify your model.
So a final thought for you to take away. The next time you're about to spin up a massive new service or write some complex conditional logic, just pause.
And ask yourself, could this just be a text file?
And if a single directory of JSON files can model a living world, what other complex systems in our lives are we just massively over-engineering?
That is the question.
This was fantastic. It really rewired my brain a little. We'll drop a link to the repo if you want to see the code for yourself. We'll see you on the next deep dive.